In this section, we're going to study the MVVM pattern, which will allow us to improve the architecture of our applications created with .NET Maui. To understand this pattern correctly, it is necessary that you understand the concept of data binding. So, if you have not seen this section, I recommend that you go back in the course and study it before starting this section. Let's start by studying the first M in the MVVM pattern, which stands for model. As part of an application, it is common to have models that represent something in the real world, such as a customer, an invoice, a weather, or anything else, and that will allow encapsulating the data of an application. This representation is commonly done through classes. Some common examples include data transfer objects or DTOs, plain old CLR objects or POCOs, and generated entities. The second letter in MVVM refers to views. We have already studied extensively how we can create graphical interfaces as part of a .NET Maui application. We have used SAML code, where we specify pages, layouts, and controls to define the different views of the application. The last part in MVVM refers to the term view model, which will be the concept we will study in this section. What does this component refer to in the MVVM pattern? Well, if you completed the data binding section, you may remember, for example, that in the event handler section for resetting a game, we reset a set of fields and properties to restart the game. This implies that we're combining application logic with the graphical interface, and although we're using data binding, this mix of code is not appropriate when we have to create applications with .NET Maui. This is where view models come into play. We have already seen that the MVVM pattern is composed of views and models. Let's introduce now the intermediate component between these two, called view model. This is the way in which the three components will interact. First, one of the views will communicate with a specific view model. This will happen using data bindings and commands, which we will study in a later lesson. A view model will communicate with a model, carrying out its update. As you can see, the communication between the components is from left to right, and not the other way around. This means that a view model or a model should not know about a graphical user interface property. What is possible is to send notifications from the model to the view model, and from the view model to the view. Let's study in a practical way how to implement the MVVM pattern in our projects.